When our SAM run finishes, the results page will look like this. The first file available for download is a CSV of the significant features and various scores that SAM assigns to them, and the statistical values that you'll want to look for significance. The second file is boxplots, and it's a PDF of boxplots of all the significant features, and it looks like this. Each feature is laid out from top to bottom by the order of significance in terms of the magnitude of the significance according to SAM. So at the top, we'll have the most significant, and at the bottom, we'll have the least significant. But there's a secondary ordering here, and there's actually two lists. The top list, which is the first 3 box plots in this case, are all the features that have a positive signal. And whether or not a signal is positive or negative is somewhat arbitrary. In this case, it's positive because day 90 is considered the primary condition and day 30 is like a secondary. And so because day 90 is higher than day 30, it's assigned a positive result. And so you can see that we have 3 positive results, but then the box plot switched to a negative results array. And so now we're starting over again with the most significant going to the least significant, just in terms of the negative results. And we can scroll through. Some features that are much lower in terms of their overall magnitude will not be as visible in the box plots because all the box plots are on the same display boundaries scale here. And that's okay because the box plots are mostly meant as a guideline, just a resource to help visualize the results. You can of course go into OMIQ and generate your own box plots and style them more efficiently. Moving on for the rest of our results, the next option is an R data file. And this is a binary file that can be read back into R and holds all of the information that was run for the SAM task. This is for more technically savvy users that want to really dig in and potentially do other things downstream with this data that we didn't do for you automatically. The next result is a CSV file of the significant features, but just the raw data that was fed into SAM. And the last option is what's called a SAM plot. This is a somewhat unique visualization that helps you interpret which features from the dataset were significant and how significant they were. The SAM plot for our analysis looks like this. Each circle is a feature, and in our case, of course, these are metaclusters and the abundances of those metaclusters. And we can see that the characteristic display of this plot is usually to have these features in the middle that are usually closer to the black line that are not significant. And then you reach a point where the features are either negatively significant or positively significant. The degree to which the feature comes off of this line indicates how significant it is overall. When they're close to the line, they're very borderline in terms of the actual significance. Oftentimes, and this visualization seems to be somewhat approximated, usually you'll see that features within the dotted line are not significant, and when they get really close to or are outside of it, they become significant. For an annotated version of this, there's another page in this PDF that also shows the labels for each of these features. Now, given how many significant results you end up having, it might get a little bit messy, but again, this is for a guideline. The other spreadsheets of information that are present in the SAM results can help you find the features just fine. So what if we had actually run a SAM on medians instead of abundance? The interpretation of the results would be fairly similar. For example, if we were to look at the box plots, we would see a similar pattern, but instead of abundances being represented by these box plots in terms of percent of total, it's the actual median signal of a particular, in this case, protein on a particular cluster. So you can see here that we're looking at cluster number 20 and we're looking at CD19. And it turns out that this metacluster, and this can happen with metaclusters, has a lot more CD19 positivity in day 90 versus day 30. Now, the thing to keep in mind when you're looking at signals like this is that the cluster could be very low in terms of its frequency. It could be kind of a noisy cluster. And so you will want to go and verify this in lower dimensional data, single cell data. Make sure that's not just a noisy cluster and that you're getting a real result. If we look at the SAM plot for our medians run, we can see that there's a lot more circles in it. And the reason for this is because we're looking at a lot more features ultimately. Because instead of the features just being based on those clusters, of which there are 20, the features are now based on the clusters times all the channels from the raw cytometry data, which is about 20 or 30. So we're looking at about at least 400 features in the SAM analysis. Here's the same SAM analysis that we were just looking at, but run again with different settings, this time only changing the FDR threshold to make it higher. And you can see that as a result, a lot more of these features were found as significant.